So back in January of 2020, I released a video called Strategies for Learning Data Science in 2020, where I shared some of my tips on how you could get started in learning data science. And so one of my favorite quotes that I would always say at the end of each video is that the best way to learn data science is to do data science. But in order to do, you also need to know. And so the trick question is, how much should you know before you can do data science? And also during the course of 2020, I've also experimented with making illustrations, explaining concepts about data science. And throughout the 1.5 years of being a YouTuber, where I got the chance to talk to other data science YouTubers, also had the chance to read thousands or 10,000s of comments, had the opportunity to read all of the engaging comments from eminent data scientists on various platforms like Twitter or LinkedIn, from some of my friends like Kenji. And so one of the most popular questions that I would see on my YouTube channel is, how can one get started in learning data science? How much should one know in order to do data science? And as mentioned earlier, there is a balance between learning about data science and doing data science. So how much should you learn before you can do data science? And so there are several videos already on YouTube talking about how to learn data science. And such videos have been released by eminent data science YouTubers such as Kenji, where he had a couple of videos sharing with you his best tips on how he would learn data science if he had to start over. And also in a hour-long video with Andrew Mo, where Kenji and Andrew Mo collaborated to talk about how they would learn data science if they had to start over. And toward the end of last year, Kenji has also released a video about how he would start over again in 2021 in order to learn data science. And at the beginning of this year, Tina Huang has released a viral video talking about her minimal input, maximum output approach to learning data science. Grish Naik and Deval Patel have also created videos of their own talking about how you could learn data science smartly and how you could learn data science for free. And also Daniel Bork has released a very good video where he shared a mind map of the topics that you should consider when learning about machine learning and data science. And so for the past 2.5 months, I've spent time watching all of those how to learn data science videos, and together with my own opinion and thoughts, I've summarized all of those concepts on how you can learn data science. And this is applicable for a beginner to data science, or also to a practicing data scientist looking to upskill or reskill, or a data analyst or data engineer looking to acquire new technical skills in order to up their data analytics or data engineer or data science skills. I came up with this infographic or cartoon illustration summarizing a conceptual framework that you can use in learning data science and also data skills. And so it's all in here. And so without further ado, let's get started. And so I've created this illustration of how to learn data science, and I've called it the art of learning data science. And let's zoom it in. Okay, so the art of learning data science is essentially comprised of 4 major steps that you can take. And so the first step will be plan. The second step is learn. The third step is to use the knowledge that you have learned to build. And then the last step is to explain. And in doing so, you could iterate to any of the 4 steps that I have mentioned. And so let's start with step 1, plan. So I've summarized some of the planning tips that you could use. And so this includes, before you start to embark on your learning journey, it is very essential to set your learning goals. And so your learning goals would be, what do you expect to come out of your learning data science or data engineer or data analytics? Are you planning to use that knowledge to get a job? Are you using that knowledge just for hobby? Or are you using that knowledge to apply in your day-to-day job? Perhaps you are already working and you would like to acquire some data science skills. So your transition would be laterally within the same organization. And so your learning goals would also come with a time. Do you have a year to learn? do you have 6 months to learn? Setting a concrete timeline for you to learn. And also, it is also very essential to create your own personal curriculum. And there are several good blog posts on Medium that will walk you through on how you could get started in selecting courses that you should take. And so I'm going to talk about some of the topics that you should learn about if you want to be a data scientist. And there are excellent videos from Daniel Borg where he went through over 2.5 hours in his mind map of how to learn machine learning. And there are a couple of Medium articles. So I'm going to include all of those links in the description of the video. And also I'm planning to make a website that will aggregate all of those learning resources in one place. So stay tuned to that. And it's going to be provided on the dataprofessor.org website, which is currently in the making. So I'll let you know when it is finished. So your personal curriculum should include some of the courses that you would like to take. And so actually, I came up with some topics for you to help you get started. And so these could include mathematics and statistics. So there are several good books on math for machine learning, and I'll also provide you the link to that. And there are several good statistics books, and the one that I have is here. Practical Statistics for Data Scientists. And so this has a lot of code example that you could work through while learning the key concepts of statistics in the context of data science. And this is also another good book to get started in learning about the essential common machine learning algorithms, the 100-page machine learning book. Okay. And so before going to machine learning, let's talk about some of the data skills that you should know. So some of the data skills that you should know would include how can you handle data? How can you clean data? How can you engineer features, combine features together, add them, multiply them, subtract them, divide them, or perform logarithmic transformation on them in order to change their or transform their values? Another essential part is how can you visualize the data? How can you select appropriate data visualization plot? Should you show it as a scatter plot? Should you show it as a bar plot, a pie chart, a forest plot, a PCA plot, a histogram plot? So that will depend on what do you want to show, what trends do you want to show in the data. And another essential data skills is model explanation. And so there are some tools that will help you. For example, Random Forest will have a built-in feature importance feature where you can take a look at the Gini index and then you could rationalize the importance or the contribution of features on the prediction. A simple linear regression, you could also make use of the regression coefficient in order to deduce which features are important and contribute the most in which direction, positive or negative, to the prediction of the variable of interest. And aside from that, the black box algorithms that will be described in just a moment here are rather hard to figure out what or how do they contribute to the model prediction. And so there are some excellent libraries that you could take a look at. And so the SHAP library in Python will allow you to examine the feature importance of black box algorithms. And so the Shapley values will tell you which features are important and contribute to the prediction. And there are other libraries such as Lime and also recently Daleks. And so you should definitely check those out. Okay, and so now to the machine learning. But before talking about machine learning, let's take a look at some of the popular or the general categories of learning. And so we have supervised learning and we have unsupervised learning, and then we also have reinforcement learning. And so it is very essential for your data science curriculum to learn about some of the supervised or unsupervised learning approach, whereby supervised learning, this means that you have a matrix of X variables and also a Y variable, whereby you will use X to correlate with Y. And so you have retrospective data that you could use to train your prediction model, which could be either a regression model or a classification model. And so given X, you could predict Y. So in a simple Y equal to F of X, where you will apply a function to calculate Y given X. And so X could have multiple X variables. And in a unsupervised, you will be learning without Y. You will only have the X features, the independent variables. So the X variables are also known as the independent variables. And the Y is also known as the dependent variables. So for unsupervised, you will only have access to X. An example of those algorithms would be clustering, because you will be able to see the relative distance between each of the data sample to one another by means of the clustering. And in reinforcement learning, the learning will occur and will improve if it gets the task that it is meant to do correctly. It will be rewarded. And so this will occur in an iterative fashion. And it's breaking down to some of the common tasks that you would do in machine learning includes classification, regression, clustering, association rule, natural language processing, and also time series analysis. So it's very essential for you to figure out which of these you would like to take a deep dive into more details. So if you already know at the start that you would like to learn about natural language processing, then you could feel free to dive into natural language processing. But if you're beginning data science and you have no idea where you want to start, then I would recommend you to start with classification and also regression, as well as clustering. And once you have mastered these three, you could also move on to tackle the other task mentioned here. And some of the traditional machine learning algorithms that I would recommend for you to take a look at includes linear regression, logistic regression, decision tree, random forest, support vector machine, and also artificial neural network. And so aside from the traditional backpropagation neural network, there are other neural networks based on deep learning. And so this includes convolutional neural network, and some of the common applications would be for computer vision, recurrent neural network, and also long short-term memory, which is for sequence processing, encoders, decoders, as well as transformers, and this is for natural language processing, autoencoders, and generative adversarial network, and this is for generative learning. And so another important topic to consider is the tools that you will be using for implementing your data science learning, as well as your data science projects. So a common question is, what computer should you buy? And so my recommendation is use whatever computer that you have access to right now. There's no need to buy any computer. So some of the best resources that you could use for implementing data science project, as well as for learning about data science, is to use Google Colab. And Google Colab is a free resource that you could use to create Jupyter notebooks that could be used for running calculations of machine learning and also deep learning, because they also provide you some free GPU resources to use. And aside from those cloud computing, you might want to also install a local version on your own computer. And so I recommend to install Conda that you could use for setting up data science environment for each of your projects. Or you could also install a virtual environment in Python. And some of the text editors or the IDE or the integrated development environment that you could use are included here. Some of the popular ones include the Visual Studio Code or VS Code, PyCharm, Atom, Jupyter, Spider, and also Vim. And some might even suggest Sublime. And very essential and perhaps one of the core skills that you should be starting to learn in your data science journey is to learn how to code. And so this could have a video of its own. And so maybe in the future, I'll be making a video about how you could get started in coding. Or I could also make a video on how you could actually take your first steps in coding Python, maybe like a Python 101 course. If you're interested in that, drop a comment. Let me know. And if you're working with a lot of data, then you should definitely learn SQL. And some of the libraries and packages that you can learn about is right here. So if you're using Python for manipulating data or data frames, you would use pandas. And in R, you would use tidyverse. And tidyverse has a lot of packages like tidyr, dplyr. And if you're using Python, if you're working with arrays, you should definitely use NumPy. And R has its own built-in array system. And for scientific computing, SciPy is also worth to take a look at. And for data visualization, if you're using Python, you should definitely learn Matplotlib, Seaborn, and there are many others like Plotly, Bokeh, Altair. And in R, you should definitely use the base plot of R and also the ggplot2. And ggplot2 has some amazing visualization that you could make of your data. And in Python, for implementing your machine learning calculations, a must would be scikit-learn. And if you want to implement deep learning models, you should definitely check out TensorFlow and PyTorch, and also Fast AI. And in R, you have tidy models, you have Parsnip, you have Caret, and you also have TensorFlow as well in R. And I've mentioned that aside from using your own local computer for calculating machine learning models, if you feel the need to expand on your computing resources, and if you are a student, you could definitely check out some of these cloud infrastructures that will provide you some free credits to get you started. And even if you're not a student, some of these infrastructures would also provide you some free credits in getting you started in your data science project as well. And one of the most important thing is also GitHub. As you're working on your machine learning or data science project, it is very essential to share those on the GitHub. So make a portfolio of that. And so I'll cover that in just a moment in the fourth part of the conceptual framework of learning data science in just a moment. And there are a lot of extensive sources of data from which you could use for your data science projects. And so these include the UCI machine learning dataset, the Tidy Tuesday, and actually I made a video about this, so I'll also include this in the description of the video. Kaggle is also a very good resource for datasets, and you could also compete in some of their engaging competition. And while at the same time, you could learn from other people's code that you could use as a jumpstart for your own projects. And nowadays, there are several datasets that are available publicly. And so do search Google for that, and you could type in open data. And also, Google has released its own Google dataset search, so you should definitely check that out. And there is a journal publisher called Nature Springer, and they had a journal called Scientific Data, where they share, as the name implies, scientific data that is published by scientists for others to use in their own project. So you should definitely check that out. Or you could also collect your own data. You could either do a survey to collect the data. You could create some Google form to collect data. User can just input their data into the Google form. Or you could also collect your data by performing web scraping. And so there are some excellent tools for you to use. And particularly in Python, you could use the beautiful soup in order to web scrape data. And if you're looking forward to deploy your machine learning models, you should definitely check out APIs that are available for you to implement some useful functions. So there are very diverse collection of APIs available on the internet, and the APIs will allow you to have access to unique functionalities, such as, for example, performing web scraping. There are APIs for that. And so some APIs are for free, while some API you have to pay. And another example would be in bioinformatics, there are APIs for you to obtain data from bioactivity databases. And so I've also had several videos about that, and I'll provide you the link to my Bioinformatics from Scratch series, where I've also gone through some of the APIs that you could use in bioinformatics. And some of the popular libraries that you should take a look at when you want to deploy your model. By deploying your models, it means that you're making your machine learning models public, you're sharing with it, and it has a graphical user interface. If it doesn't have a graphical user interface, it is called an API. But if it has a graphical user interface, you could call it a web app. And some popular ways for you to do that is to implement Flask, Django, but two of these would require a lot of technical skills. And there are also Dash and Streamlit. And so these two are a lot easier than implementing in either Flask or Django. And by easier, I mean that it will take you less time. And so I've also have a whole video series on how you could implement several of your data science projects using Streamlit. And with Streamlit, you could deploy your machine learning models, you could deploy your deep learning models, and also create an interactive data application. And so you should definitely check the video playlist that I have created. And there are almost 20 videos so far, and the playlist is growing. So definitely check that out. And another important part of the data science curriculum is the data science process, or sometimes you could call it the data science life cycle. And so in a nutshell, it includes some of the tasks that you would normally encounter in doing data science. And so you could think of this as kind of like a blueprint for doing data science that you could refer to some of the best practices that data scientists used when they implement a data science project. And so this can include data collection, data cleaning, data modeling, data exploration, data deployment, and also interpretation. And so I've also made a video about that, and you should definitely check those videos out, and the links will be provided in the description as well. Okay, so Now that we have the core elements of the data science curriculum mentioned, let's head on back to the big picture. All right, so now we have the data science curriculum clear. You should definitely make a schedule for learning data science. So Kenji has an awesome initiative that you could use to jumpstart your learning process. And I know learning data science could be a very enduring process. And so without the commitment, without the accountability, it is very difficult to succeed in learning data science. However, this is also not the case because of the recently created initiative of Kenji, where he mentions that in order to participate in the 66 days of data, you are required to learn data science for at least 5 minutes a day. And then you're going to be sharing what you have learned on various social platforms like Twitter or LinkedIn. And so by doing that, you will be accountable for your learning process. And so not all days are productive. So for some of the days that you're not productive, you could also spend it watching some data science videos, maybe some videos from Data Professor channel as well. So the great thing about the 66 days of data is that it allows you to have a concrete schedule that you will have to implement and also be consistent in your journey, your learning journey. And aside from that, when you're posting on various social platforms, you also feel the urge to learn. You also feel that you are accountable, that someone in the world is knowing and waiting for your update, what you have learned about for the day, for the week. And so accountability is an important part. It's kind of like when you're in college or you're in high school and you have an assignment that you have to submit to your teacher. So you are accountable for that. And so the thing is, if you're in a data science master's degree or a PhD degree or a undergraduate degree, you have accountability in that you have to submit your assignments. You have to do your coding assignments, and you submit it to your teacher so that your teacher will give you some grades for it. But for those of you who are learning on their own, you are a self-learner, it might be difficult to have accountability. And therefore, if you share your learning process, that accountability will no longer be an issue. Okay, so now that we have the first part of the art of learning data science covered, let's move on to the second part. And this is the process of learning. And so some of the learning resources that you could use to learn data science would be to watch. You could watch YouTube videos, or also you could watch videos on various learning platforms. And there are DataCamp, 365 Data Science, DataQuest, Skillshare, Udemy, etc. You could also listen to podcast video on YouTube, on Spotify, on SoundCloud, and there are several great podcasts on AI and data science. And so you could run, you could jog, and then you could listen to data science. You could drive to work and listen. You could commute to work and listen on podcast. And actually, Kenji has an awesome podcast called The Ken's Nearest Neighbors. And so you should definitely check that out. And aside from watching YouTube videos or listening to podcasts about data science, another way would be to read. And some of the resources that you could use would be to read books and also Medium articles. And so books such as the 100-page machine learning book, Practical Statistics for Data Scientists, Approaching Almost Any Machine Learning Problem from Abhishek. And he also has a great YouTube channel where he goes into detail about implementing various machine learning projects and also deep learning projects. So you should definitely check his channel out. And you should definitely not miss this book. This is a must-have book if you're getting started in machine learning and also data science. So it has a lot of great examples, and it's going to cover important machine learning and deep learning libraries such as scikit-learn and also the Keras and TensorFlow. Okay, so definitely this should be on your wish list or your buy list of books to buy for your data science learning. And I mentioned that R also has deep learning. And so actually I bought this book out, and you should also check that out if you are a R user and you would like to implement deep learning. Or if you would like to use Python and you want to implement deep learning from scratch, then you should definitely check out this book. And also in the background that you see here, I also have several books that I'm looking forward to learning about in machine learning and also deep learning. And so as you see here, learning is a lifelong process, and data science is a very big field, and it's simply impossible to know everything. And once you think that you know a lot of topics, then there will always be some new topics being released, being published. And so the learning will never stop. And so one of the most important thing of being a data scientist is to have a love for learning new tools, for learning new machine learning algorithms, for learning new frameworks, for learning new libraries. So the learning never stops. And so here are some of my tips for learning. And the first one being, and also mentioned by other YouTubers such as Kenji and also Tina Huang in her minimal input, maximum output video, is to learn just enough to get started. So I mentioned earlier on in the video that how much should you know before you can do? And so some of the tips that I would use when approaching a new machine learning library that I would like to use in my project is to go through the API list, have that handy, right? Take a look at the names of the functions, take a look at the input argument, take a look at what does the function do, what does the input that it uses, and also what does the output look like. And also to look through some of their getting started sections, and most likely they will have some tutorial or step-by-step notebook, Jupyter notebook, where they implemented on a example dataset, such as on an iris dataset or other example dataset. And then the thing is to figure out what is the input data and then what is the output data that came out and what is the purpose or what is happening under the hood of the various functions of the package that you're using. And if you can understand just that, you could practically get started in implementing any new machine learning libraries or tools for your projects. So the input, the output data, and so how did the input become the output? What type of calculations are implemented to transform the input data into the output data? Okay, so let's use the random forest classifier as an example. And so the first thing that you would do is you would import the random forest classifier function from scikit-learn, such as from sklearn.ensemble import random forest classifier. And then you're going to be creating a variable called CLF, and then you could assign that random forest classifier, and then you have the opening and closing parenthesis because it is a function. And actually you could leave the input argument blank, and it will be using the default parameters. However, if you would like to specify the parameters, you should definitely check out the API. And then you will see what input arguments are available in the API. For example, you could set the number of trees, you could set the number of leaf node, maximum leaf node, etc. And then afterward, you would perform the model.fit or the classifier.fit. And then the input argument would be the X and the Y variables, right? Because after fit, you would have already trained the model. And then you could also apply the model that you have already trained to make a prediction. Okay, so after you have learned enough and then you are able to implement that in a data science project, another very useful advice would be to apply some form of time management to your learning. And a popular approach is to use the Pomodoro technique, where you work for 25 minutes and you are engaged in a deep focus of working. And then for every 25 minutes that have passed, you would take a 5 minutes break. And so this will constitute one cycle. And so you could implement several cycles as you go along in your data science learning journey. And you could also set a concrete time. Like for example, you could spend maybe one round of Pomodoro to learn about how to use random forest classifier. And when that round is up, you could shift to learning on another topic. And so that will help you to prevent getting stuck on a particular topic, prevent you from going down the rabbit hole, and you will be able to move on to the next topic. Okay, so if you're stuck, you could move on and come back later. And other resources aside from books would be to read Medium blog posts, articles. And I've actually published several articles in Towards Data Science, where I go into step-by-step detail on how you could implement data science projects. And so Medium is also a very excellent resource for you to learn about data science. So you should definitely check that out. And there are several platforms that will allow you to do data science. And I've mentioned briefly that there are learning platforms such as DataCamp, 365 Data Science, and also Data Quest. And so you could check those out as well for learning about data science. And now that we have already covered part 2, the next step will be to build, and you will be now implementing the knowledge that you have learned to build projects in data science. And so here are some of my tips for building projects. If you are acquiring data science skills for an existing job that you know, so you could work on work-related projects. So you could figure out which project that you have to do, talk to your boss, and figure out how you could apply data science to solve that problem. And so that will allow you to acquire data science skills on the job. And so this will require you to self-learn as well, and also use the resources that we have talked about. Or if you're not able to learn data science on the job, you could also consider working on weekend projects or project during your off hour. So your 9 to 5, you will be working. And so for your 5 to 9, 5 p.m. to 9 a.m., you could figure out how you could work on some side project that will allow you to implement some data science project in your learning. And I've already mentioned some of the public datasets that you could use, or you could also compile your own. And also you could compete on Kaggle, and there are excellent engagement in the community. And you could also definitely learn a lot from the existing notebooks that are shared on the Kaggle platform. And the last part of this art of learning data science framework is to explain. Once that you have already built your data science projects, you need to explain it to someone. And explaining to someone can come in many forms. And the process of explaining will help you to materialize all of the knowledge, all of the practical skills that you have acquired in data science into a concrete form that have internalized and materialized into you. So now the knowledge and the practical skills are engraved into you when you are explaining. Okay, so there are several approaches to this, and I have listed here. And so this includes teaching it to others. If you teach your data science models to others, like how can they implement a similar approach and how you can make the explanation as simple as possible. And so this is called the Feynman technique. Another one would be to mentor others. Maybe you have a friend who would like to learn about data science. You could mentor them. You could write blog posts, write on Medium, publish in Toward Data Science. You could build a well-documented GitHub portfolio about your projects. You could make YouTube videos about them. You could give talks at meetups, at conferences, or also participate in podcasts. And so there is an excellent data science podcast on the Chai Data Science Podcast. So you should definitely check that out. And also the one from Kenji. And most importantly, for me at least, is to draw infographics that will explain about the concepts of data science. And so I like to do this as well. And therefore, this is the infographic that I have drawn to summarize some of my best tips on how you could get started in learning data science. And so I call this the art of learning data science. And so if you're finding value in this video, please help us out by sharing the video, smashing the like button, subscribing to the channel if you haven't already, and also make sure to hit on the notification bell. And as always, the best way to learn data science is to do data science. And please enjoy the journey.